Okay. Yeah, it was in there. All right, so our unit circle, this is what we've got going around our circle. Yesterday we said the domain is what? All real numbers. We can plug in any theta that we want. Okay? So my domain will be all real numbers. There's not two L's. Real numbers. But what is the domain? What will I get out? Okay? I don't want you to say anything. I want you to think. You've got outputs going around that whole circle. Can we talk about the X's? It doesn't. I wrote Y. Can we talk about the Y's? Sine theta. What outputs can we get when we plug in any theta? Okay. What can our outputs be for Y's? What can the output, the range, what is it going to be? You know what maybe I might do? Look at that. Wait. I said don't say anything. We're all thinking. Okay. Around this circle, do you have Y values? Look at them. What's happening with them? What's our first Y value? I thought it was 1/2. The Y values. What's the next one? And the next one? Over 3/2. Output. 1. Next one. It's the same ones. And are they all positive? The Y's, so we're just talking about the Y's right now. So for the Y's, for sine, does everybody know what a half is? Yes, 0.5. What is the square root of 2/2 as a decimal? What's the square root of 2/2 as a decimal? What about the square root of 3/2? 0.87. We all know they keep going on forever and ever. That's a decimal. Okay? And then we get to 1. And then what happens after 1? It's going back down to 0.87, to 0.71, to 0.5, to what? Bless you. Oh, to 0. Okay, so the Y value starts where? At 0. It goes up to 0.5, 0.7, 0.87. If we plugged in other numbers in between there, if we plugged in sine 75 degrees, we don't have exact values. We can plug in all the decimals, right? All the other thetas, not just the exact ones that we know. We could plug in sine 72, sine 87. We could plug all those in, right? What's it going to go up to? We're starting at 0. It's getting bigger. It's getting bigger. It's getting bigger. After 90 degrees, after it's 1, what happens? It goes back down till you get to what?
0.
Back to 0. Okay? Well, let's keep going on the bottom of the circle. At this one, what did you get? Negative 1/2. Okay? So is this negative 0.5, negative 0.7, negative 0.8 until we get to what? Negative 1. Oh, should we go to the 4th quadrant? So we get to what? Negative square root of 3/2. Negative. Okay. So we're getting smaller. We went to 0. We're getting smaller. 0.5, negative 0.5, negative 0.7, negative 0.8 till we get to -1. Then we go back to -0.8, -0.7, -0.5, until we get back to what? 0. Can we talk about the range of sine? What are ranges? If domain is the input, like we talked about yesterday, what is the range? The output. What we're getting out. So the range, I'm going to put of sine. I usually don't put equals. I usually put the colon. What can it be? What can it go up to? What can it go down to? It goes down to -1. It goes up to 1. Can it ever be greater than 1? No. We're going around a circle. It doesn't matter what degrees we put in. Oh. What if our circle's bigger? Does it matter? We'll be dividing by that bigger number, and it's still going to be a fraction. Whether our radius is 2, or 7, or 175. Okay? We were just dividing by a bigger number then. So the range of sine, can we say? Now, all real numbers, I probably should write them correctly. I don't do little brackets very well. They're these things. I do it better going this direction than that direction. But that's what that's supposed to be. A little better. If I take my time, I can do it a little better. Is it so much better? Okay, so my range, my output. What do we call outputs? What's something else we call outputs? Well, I probably should go back and rewrite to that one. Other than the range. The y values. Can y be the set of all real numbers? Such that. Sometimes we have a such that. Sometimes there's a restriction. Meaning, can I plug in, or can I get out irrational numbers? I am. They're decimals that are going to go on forever. You can get out square roots. Okay? So I don't want to say they're between 1 and -1. Because that gives me the connotation that it's only going to be, well, 1, 0, -1, those integer type numbers. Okay? Have you seen me do the set? Have we done of all real numbers? I need to go back. Such that actual correct interval notation. See, sometimes I assume that you don't ever do it in algebra 2. And I don't know when I do it here. Can y be equal to 1? It's kind of a backwards one. All real numbers. Let me read this to you. Okay? Because it is in every Algebra 1 book. It's in a lot of I know it's in every Algebra 2 book. Okay? The set of whole numbers. How do you know what are the set of whole numbers? What are whole numbers? Okay, a little more specific. 1, 1.1, 1.2, 1.3, 1.4. Those whole numbers? What are they? What is the set of whole numbers? 1, 2, 3, 4, 5, 6, 7. Etc. How would we write that? So I started making my pre-algebra kids write it in set notation. Okay, I don't think I did it with you guys. Okay, domain, all real numbers, we need a set. X is the set of all real numbers. That is better than that. They say the same thing. That little cursive, weird looking E, are talking about the elements. What are the elements of the whole numbers? So let me go over here. Oh, that's a weird green. Whole numbers. Set notation has the brackets. you would put 1. I would not put that. 2, 3, 4, dot, dot, dot. That is set notation. Okay? With the brackets. Okay? We're going to start writing things in set notation. There are two different, there's set notation and there's interval notation. Most places will use set notation. So if you see the brackets, which are these little things, that's set notation. Okay? What about if I want to know what's the range of sine? Let's change what color I want, not purple. Of cosine. What is the range of cosine? So what am I looking at? The x's. What happens? What are my x's starting at 0? 1. Then we have square root of 3 over 2. Do we already know what square root of 3 is? 0.87. Then we have then 1/2. So we're starting at 1. We're going down to 0.87. We're going down to 0.71. We're going down to 0.5 until we get to what? 0. Then we're making a turn after 90 degrees. What's the x value with this one? With 120? Negative 1/2. So we went from 0 down even farther, down to negative 1/2. Down to negative square root of 2 over 2. These are commas, I guess. And then we go to negative. So we went from 0 to negative 0.5 to negative 0.71 to negative 0.8 until we get to what? Negative 1. So we keep going. Are we going to keep going down? Negative square root of 3 over 2. Is that down? Is that farther? Is that less than negative 1? No, it's going back up. It's going back up from negative 1 back up to negative 0.87. To negative what? Negative 0.87, negative 0.71, to negative 1/2 until we get back to what? 0. So we're actually increasing up to 0. Then what happens? It goes back up to 1/2. So they're positive, right? 2 square root of 3 over 2. So it's increasing still to 0, 1/2, and 0.71, 0.87, until we get back to what? 1. So what's happening as we go around our thetas? If we kept going around, what outputs will we get? What would our range be? Is it going to be the same as sine? Can we ever have a number, an output greater than 1? Can we ever have an output less than negative 1? So your y's, your outputs, is a set of all real numbers. If we can get out any real number as outputs, but we have stipulations. It has to be greater than or equal to 1. It must be less than 1. It's going to be between negative 1 and 1. Set notation. If we wanted to look at, if we want to take time, that's the big question. And look at what are different types of notations. Okay. There's a notation that's called interval notation. And that's how they would write it. If they were writing interval notation with this one, they would write the exact same way. I did not change colors, and I thought I did. What about all real numbers? What do you think it would be for all real numbers? Negative infinity to positive infinity. I did something a little different in that one. I did parentheses and not brackets. Okay, it's not bound. What do you mean? There is not an and. It can't equal. The brackets mean it will equal 1. It will equal negative 1. It will equal, but we are never going to equal infinity. Yes. I can never write whole numbers like this because it's saying it's going from this to that. It's almost like a coordinate, but it's not. Okay? You have to understand what the problem is because sometimes you'll have numbers in the middle with parentheses. You're like, what? Why in the world? If I did tangent, we won't talk too much about tangent, but sometimes there'll be a bracket on one side and a parentheses on the other. I know. From 0 to 90 degrees. Tangent. Can tangent ever equal 90 degrees? No, it's undefined. So we would put a parentheses because it's never going to equal 90 degrees. We can never plug in 90 degrees. That's not an input for tangent. Okay? All right. I feel like I've given you more than you need. They do talk about the domain. They talk about the domains of tangent and cotangent, and I won't. I don't like their definitions of them. You have to know where they can't equal. We'll talk about that later. I'm not greatly concerned. We did this in the last section, so I'll make assumptions that we can still do it. If I say, what is cosine 7 pi over 4? What are you going to tell me? Find the exact value of. Could we use that circle that we just looked at in your book to find where is 7 pi over 4 and cosine? Is cosine the x value or is cosine the y value? It's the x value. Cosine goes first. It's kind of weird, I know. It confuses me. It's the x value when you are looking at that circle and you say 7 pi over 4. Or you're looking at your plate, right? 7 pi over 4 is your middle color. In which quadrant? In the fourth quadrant, so we know it's positive. Cosine. And what's your reference angle? What does it match up with? Only 315, but the reference angle is 45 degrees. So what is cosine of 45 degrees? Square root of 2 over 2. And it's positive because we're in the fourth quadrant. Okay? So now I'm going to ask you a question. What if I change this problem to say cosine theta equals the square root of 2 over 2? Oh, I need to give you a little bit more. This is when some of those intervals are going to come in handy. Okay? I'm going to say I want between 0, I'll be nice, how about that? 0 and 360 degrees. And I won't give you radians. Why did I use a bracket for one and a parentheses for the other? I want it equal to 0. It can equal 0. But why would I not want it to equal 360? I might get 2 answers if I've got a 0 where it's going to land. I and I don't want it. I just want for either 0 or 360, they'll be the same answer, but I only want it once. So how many times around your circle could cosine theta actually equal square root of 2 over 2? I see some people have held up numbers. How many times can it equal it? Twice. Why? Can I look at which? I mean, you already have an answer in this one. Around your circle, where is cosine positive? Okay. So my theta can be right here, or my theta can be all the way around to this. Okay? But should my reference angle be the same? Yes. So what should my reference angle be? That's going to be what it is in the first quadrant, which is 45 degrees. So should that be one of my answers? Theta can equal 45 degrees. What else can theta equal? 315 degrees. When we did this problem, 7 pi over 4 was 315. Found our reference angle, so we kind of gave you that one. Okay? Because I almost wanted this answer in radians, but I was nice to start. Could I ask you for the answer in radians? You've got your plate, it's there. Pi over 4, 7 pi over 4. You're there. Can we work another one? What if I ask you sine theta equals negative square root of 3 over 2? Over the interval from 0 to 360 degrees. Oh, I need to get girls and pies. Forget. This one doesn't have the answer right beside it. Be a little bit harder. What might you need to know? Or if you're looking at that circle in your book, that won't always be in front of you. What are you looking for? Is anybody going to draw a triangle? If I draw a triangle, what am I thinking about? An opposite, that is square root of 3, and a hypotenuse, that is 2. Maybe you think that. Maybe you automatically know what it's going to be. I don't always remember. And then I have to finish my triangle, so that would be a 1. What's always opposite 1? 30 degrees. So what is my theta? What angle is it? 60 degrees. Is my answer 60 degrees? But what is 60 degrees? The reference angle. Okay? Why is 60 degrees not my answer? Because it's negative. In the first quadrant, 60 degrees, sine 60 is going to be positive. Okay? So I need to draw my chart. Where is sine negative? The third and the fourth quadrants, and I need a reference angle of 60 degrees. My reference angle, I need it to be 60 degrees. So maybe I look at my plate and say, where do I have a reference angle of 60 degrees? Or I say 180 plus 60 and 360 minus 60. I mean, I can still figure it out without having my plate right beside me. So what did we get? 240 140 degrees, and 300 degrees. If you have your calculators out, try it. What is sine 240? Get a decimal. What is sine 300? You get the exact same decimal. So two different inputs give me the same output. Is that okay? It kind of has to be. Yeah. You want to do one more? Can I give you? I only got 3 minutes. Can I give you one to plug in your calculator? If I say find a calculator approximation for. I really shouldn't have to do this. I feel like we can remember it. Ooh, no. That's what I'm like, there's a reason that I was doing that, and I shouldn't question myself in the middle of it. I should just do it what I thought first. If I give you cosine 1.85, say find a calculator approximation for each circular function value. What do I not have up there? The restrictions, okay, but I give you an input. If I say between 0 and 90 degrees, I guess I can have a bracket there because it's cosine. But, what is 1.85? Okay, I'm going to go back to the last slide really quick. What did we plug in our calculators? Degrees. If there are no units, what are we in? All of a sudden, radian mode matters. Okay? So we are actually at 1.85 radians. So we're more than 90 degrees. That's why this is on my way. You asked me, and I'm like, oh, sure. But that does not need to be there. So now if you change your mode, does everybody know how to change their mode? Mode, you go down, you arrow over to radian. Now when you plug in cosine 1.85, you should get, it should be a negative first of all. The first one you got was positive. Negative 0.2, negative 0.2, there's a 0.28, etc., etc., etc. Okay? Radian mode will be when we're using trig functions instead of degrees. Now wait, everybody change your calculator mode back to degrees, just in case you're going to physics, and you don't need it in radian mode. I don't know. Sorry. Taylor.